Hello everyone. Myself Samyak Mishra, fourth year mechanical engineering student of NIT Warangal, and I am going to explain about my robotics assignment on manipulability. So this is my problem statement. So in this question, we have to calculate the manipulability for two robotic manipulators for case A and case B, and we have to compare the manipulability and find which design is better of the two. So before solving the question, first we need to understand what manipulability means in the field of robotics. The manipulability measure represents the ability of a manipulator to control its end effector in different directions. A higher manipulability measure indicates a higher ability to control the end effector and reach a larger workspace. The manipulability is determinant of the Jacobian matrix calculated at different positions of an effector during its path of motion. To determine which manipulator design is better, we can compare the manipulability measures for the two cases. By examining the plot of manipulability measures for the two cases, we can make a comparison. Based on the plot, if the manipulability measure is consistently higher for one case across different positions, it suggests that the manipulator design associated with that case is generally better. Generally better. So code for calculus. So first, I created a MATLAB code to calculate the Jacobian matrix and manipulability, and then the plot of manipulability with respect to x coordinate of the end effector. So going to the code, first I defined the link length. For case A, L1 was 0.5 meter and L2 was 0.5 meter. For case B, L1 was 0.625 meter and L2 was 0.375 meter. Then the initial and final position for the end effector were defined. So initial position was 0.25, 0, comma 0, and the final position was 0.95, comma 0, comma 0. So the increment value in our case was 0.05 meters. So it was defined as this. So then the number of steps were calculated by using this formula in the MATLAB, and it came out to be 20 using this formula. So to store the data of the Jacobian matrix and the calculations, we first need to initialize the arrays to store the position and manipulability measures. So we created four arrays, two for case A and two for case B. Then for performing the calculation of the Jacobian matrix at each different position, we initiated a for loop which consisted of 20 iterations as in our case. So this is the code for calculating the Jacobian matrix, and this is the code for determining the determinant of the Jacobian matrix, which in our case is manipulability. So after calculating the manipulability for each position, we generated plots between the position along x-axis and manipulability. So the y-axis was manipulability, and the x-axis was position along x-axis. So after running the code, we got these two graphs. The manipulability measure graph for case A is this, and the manipulability graph for case B is like this. So in this graph, manipulability is on y-axis and position along x-axis of the end effector is along the x-axis. So now coming to the conclusion, by examining the plots of the manipulability measure for the two cases, that is this, uh, we can see that the manipulability for case B robot is greater throughout the position along x-axis as compared to the case A. So we can conclude that case B robot manipulator is better in design as compared to case A, as higher the manipulability throughout the position along x-axis, better is the uh, working of the robot. So we can say that case B with L1 link one length of 0.625 meter linked to length of 0.375 meter is better designed as compared to case A robot with L1 and L2 of 0.5 meter. So this concludes our question on the robotics assignment. Thank you for listening to me.